What's up? My name is MathYou, and in this video I'm going to talk with you about information from Chapter 1, Section 1 in a college algebra course. And I have these pre-printed notes that I'm going to go through and sort of talk about some aspects of them, and then we'll get to some practice problems where I will write out some solution processes, and hopefully these notes will be helpful to you as you're going through and completing homework assignments or prepping for a test. So let's get started. And let me bring the mic a little closer so that you can actually hear what I'm saying. There we go. In Chapter 1, Section 1, we're talking about graphs and graphing utilities. In the course that I teach, I don't use a TI graphing utility, graphing calculator. So I'm going to abstain from using that in this video also. We don't need that material at the top there. There we go. This is the Cartesian coordinate plane. It was first designed, so to speak, by René Descartes. And he takes the entire plane and cuts it up into these 4 different quadrants. So please note where how the quadrants are labeled. And that 0, 0, where the x-axis and y-axis meet, is referred to the origin, and that it has coordinates 0, 0. On the Cartesian coordinate plane, we can plot points. We're given ordered pairs like -5, 3. And in the 4th quadrant, you can see that we've started at the origin. We've moved to the right 3 points because the x-coordinate, I mentioned -5, 3. So let's go into the 2nd quadrant. And you can see that we've started at the origin, which is 0, 0, and we've moved left 5 units. So that's 5 units in the negative x direction, and then 3 units in the positive y direction, which puts us up into the 2nd quadrant. And then you can follow that same rationale and line of thought to the point that's in the 4th quadrant, with coordinates 3, -5. 3 units in the positive x direction, 5 units in the negative y direction. When you graph an equation, what you're really doing is graphing a relationship between 2 different variables. And the graph of a line, or if it's the graph of a parabola, whatever it is, each one of those graphs is made up of, at least those 2 graphs that I just mentioned, is made up of infinitely many points. And there's an equation typically that describes the graph that you're looking at. And if you take any point on the graph, that point's going to have coordinates, x, y, and you should be able to take those 2 values, x and y values, plug them into your equation, and it will satisfy or make that equation true. We'll see more of that as we go along for sure, but just generally speaking, that's what a graph is. It's a visual representation of a relationship between 2 variables as described very typically by an equation. If you're given an equation like this one, y = 4 - x squared, you can sort of engineer the graph by taking some x values, plugging them into the equation, and doing some arithmetic and generating the corresponding y value. For example, here we're using an x value of 3. 3 has been plugged in or substituted in place of x. So instead of taking x squared, we're taking the 3, we're squaring it, we get 9. Now we can do 4 - 9 and get -5. And there's one of the points that we were seeing on the graph on the first page of these notes. Just from looking at this equation, y = 4 - x squared, if you didn't know what that graph looked like, if you didn't know that that's an upside down parabola slid vertically up 4 units, then you could take a handful of x values, plug them in, generate the y values, plot those handful of points, and probably have a better idea of what your graph's going to look like. And that is the point plotting method. If we're going to graph this equation, we can take these x values and plug them in one at a time and generate the corresponding y values. Let's just use 3 x values. How about -3, 0, and +2. So we'll take y, that's equal to 2 times -3 minus 4, that's -6 minus 4 is equal to -10. Take a 0, plug it in, we've got 2 times our new value of 0, minus 4, that's 0 minus 4, which is -4, plug in the 2, 2 times our new value of 2, minus 4, 4 minus 4 is equal to 0. So I'll take the -10 and write it in as a y-coordinate, the -4 as the y-coordinate, 0 as the y-coordinate. And now these are ordered pairs. Those are points that we can plot. So let's go down here onto this graph and plot the point -3, -10. 1, -2, -3, so I'm going 3 units in the negative x direction. And then we'll go down 10 units, 1, 2, 3, 4, 5, 10. There we are, -3, -10. The other point, or another point that we saw, is 0, -4. So we'll move 0 units horizontally and only come down 4 units and plot that point. And the other point that we plotted was, or that we calculated, was 2, 0. We plugged in a 2 for x, we got out a 0 for y, so I'm going to move 2 units in the positive horizontal direction and 0 units in the vertical or y direction. That gives us this point right here, and let's see how I'm doing with freehand. That's almost a line, but you can see, especially by plotting 3 points, just in case you messed one of them up and those 3 points didn't end up being collinear, here you can see that all 3 do indeed fall on the same line. We could pick any point on this line, like this point, or this point, or this point, and find the x and y coordinates for that point, and then we could take those values and plug them back into this original equation, and it would make this equation true. Intercepts, the x and y intercepts, are the points where a graph crosses the x-axis, that would be the x-intercept, and the point where the graph crosses the y-axis is called the y-intercept. Visually, graphically, we can see examples of those here. Here's a point where we are not actually crossing the x-axis. The graph is just coming down and touching it and then going back up, but that does still count as an x-intercept. 2 units to the right of it, this point, is another x-intercept. And this point that's up here, where the graph does indeed cross the y-axis, is a y-intercept. So if you wanted to draw a little sketch of this in your notes, if you need that reminder of what the intercepts are, just conceptually and here visually, that would not be a bad addition to your notes. And the way that this is phrased, in part B, it says we have x-intercepts at -1 and 1. So there's sort of an understanding that -1 and +1 there are x values because we're talking about an x-intercept. Let me ask you this. These x values of -1 and +1, they do pertain to these 2 points right here. What's the y coordinate at those 2 points? The answer is 0. Vertically, we haven't gone up or down away from the x-axis. Is it always true that the y coordinate of an x-intercept will be 0? And the answer is yes. And sometimes that's going to be very helpful in helping us determine x-intercepts. We can assume safely that if there is an x-intercept, we can let y equal 0. So sometimes we'll plug in a y value of 0 in order to do some algebra, some arithmetic, and find the x-intercepts. Similarly, this point up here, well, there's a 1 here for our y-intercept, and that corresponds to that point right there. That y-intercept has a y value of 1 and an x-coordinate of 0. Is it always true that a y-intercept is going to have an x-coordinate of 0? The answer is yes again. And that's the end of section 1. Which means I'll see you in section 2. Thanks.